Hi, everybody. So in honor of over 100 subscribers, I thought I would give you some wholesome content and show you Lilo over here on the camera. She likes it when I scratch her chin. You can see the smile on her face. So thanks, everybody, for subscribing. I wanted to start off this video with a cute doggo. Say hi, Lilo. Look into the camera. Tell everybody hello. She's weird. She doesn't look directly into the camera. Okay, so as fun as that was, today we are going to talk about perimeter and area. Perimeter and area is something that is super important when we are dealing with geometry. And it is something you've probably experienced before. However, in our class, instead of just having everything given to us in order to find perimeter and area, a lot of times what happens is we're only given certain pieces of information, and we kind of have to set up and solve equations to figure out the total perimeter of something, or maybe the missing length of one of the sides of our shapes, or maybe we need to find the height of one of our shapes, the width of one of our shapes, just given a certain amount of information. So in this video, we're going to go over the definitions of perimeter and area and the formulas that we need to use when we're solving the perimeter and area of different two-dimensional shapes. So the first thing we're going to cover is we're going to talk about perimeter. So perimeter, the official definition is the distance around a shape. The distance, you can even put the distance measured, because we measure it, measured around a shape. So if I'm given something like a triangle, I'll draw two different triangles here. The perimeter is going to be this total distance, or this measurement around all three sides of the triangle. And the way that we calculate the perimeter, or this distance, is we simply just calculate by adding all the sides. So we calculate, spelling is hard. Calculate by adding, these sides. And if you have more room, you could put side lengths. Sorry, that looks a little messy. So let's say we have an example of a triangle, and let's say that the length of this side is 6, we'll measure in centimeters. This one is 5 centimeters, and this one is 10 centimeters. Well, to find the perimeter, or the distance around this triangle, I am simply going to take 6 plus 5 plus 10, and that is going to equal my perimeter. So 5 plus 6 is 11, plus 10 is 21. So my perimeter is equal to 21 centimeters. A lot of times in word problems, you'll see perimeter being used like, this person needs a fence to put in their backyard. And if the perimeter, if the length of their yard is this many feet and the width is this many feet, and it's a rectangular backyard, how many feet of fencing do they need? And really what they're asking you to do is find the perimeter. Sometimes though, we may be given the perimeter. So let's say in this triangle, let's say the perimeter is 100, we'll use feet, okay? And all they tell us is that this side is, let's say, 70 feet. This side we'll do 15 feet. And they don't tell us the third side length. But I don't necessarily need the third side length, because I can use the perimeter and the other two values that I'm given to figure out what the missing side length is, because I know to find perimeter, all I have to do is add up all the sides. So I know that 70 plus 15 plus x, that should all be equal to 100, because that's my perimeter. That total distance around should be 100 feet. So now I have an equation, and what I can do is I can follow the 3-step process to solving equations. So I can combine my like terms. I'm going to combine my constants. 70 plus 15 is 85. 85 plus x equals 100. And to get x by itself, I'm going to use the subtraction property of equality, my SPOE, to figure out what is that side x equal to. 100 minus 85 is 15. So that missing side length is 15 feet. Sometimes they may say this is 2x, or it is 4x, or it is 0.5x. And if you set it up kind of like an equation, once you have it set up like an equation, you just follow the process we've been using to solving equations. Okay, so perimeter is the distance measured around a shape, and all we do is calculate by adding up all the sides. And knowing that formula, we can find the perimeter of any shape, not just triangles, but rectangles, parallelograms, trapezoids. When we get into circles, we learn a specific formula, but for any polygon shape, quadrilateral, we can use this process. Area is the other thing we're going to talk about in this video. So the official definition of area is, focus, there we go, is the space within a two-dimensional shape. So sometimes this word space gets confused with volume. Volume has to do with three-dimensional shapes. A shape has to be three-dimensional in order for it to have volume. We call the space within a 2D shape the area. And the way that we calculate this, we calculate by using specific formulas. So there are formulas that have been kind of discovered for each different kind of shape. And essentially what we do is we use these formulas and we use the different parts of the shape in order to figure out the area. So for a parallelogram, square, and rectangle, anything that classifies into one of these categories, parallelogram, square, and rectangle, the way we find the area is we take the length times the width. I'm using the cursive L. So we take the length times the width. And so if I have something like a square or a parallelogram, typically the length is the longest side. So this is a square, so there's not really a longest side. All the sides are the same length. But typically, like in a rectangle, we think of the length as the longest side, and then the width is just the side that is perpendicular to the length. So length times width is how we find the area of any parallelogram, square, or rectangle. When we have a triangle, and I'm going to put a square, or actually it's more like a rectangle, around the formula. When we find the area of a triangle, we find the area by taking our base and our height of our triangle and multiplying them together. Notice how I'm not using the multiplication symbol. If I put B and H right next to each other, that means multiply. So I'm going to multiply my base times my height, and then I am going to take half. So this formula, 1/2 base times height, is the area formula for a triangle. So in a triangle, our base and our height, they look different depending on the triangle, but you can think about the base as one of the sides of the triangle. It's typically the side that we kind of reference as like the bottom part of the triangle, and the height is how tall the triangle is from the base at a right angle. Okay, so again, depending on the triangle, it can look different. In this triangle, the height, this is the height right here, this dotted line, it is forming a right angle with the base. If I have a right triangle where this angle is 90 degrees, this smaller line, let me zoom in a little so it's easier to see. This is the base, and then this is the height, because this is where it forms a right angle with the base. So the height is wherever it forms a right angle with where the base is. Sometimes your height can be outside of a triangle. Like if you have a triangle that kind of looks like this, what we call like an obtuse triangle, I'm trying to draw it as straight as possible. Okay, where it's kind of like slanted, the height can be measured outside, because again, it's wherever it forms a right angle with the base. If this is the base of the triangle, the height can be over here on the outside. So essentially, when we're given the base and height of a triangle, we multiply them and then take half. in order to find the area of a triangle. And then for a trapezoid, this is the last kind of shape. The area formula, it looks a little crazy, but it's actually a three-step process, but it's pretty simple. So in a trapezoid, I'm going to draw it as I write down the formula because it'll probably be a little easier to see. A trapezoid could look like this. We can also have a trapezoid where instead of like one side being slanted like this, it could kind of form a straight line. It could look like that as well. To be classified as a trapezoid, it just has to have one set of parallel lines. In this case, it kind of has two. So in a trapezoid, we have two bases, technically. So typically we label the top base like base 1, and we write it with B and then a little 1 next to it. And we label the bottom base base 2. So we have these two bases in a trapezoid. And again, we also have a height. The height is going to be where if you measure from the bases where it forms a right angle. So typically the height in a trapezoid is kind of measured over here, kind of where the side and the top or the bottom base like meet. So again, where it forms a right angle with one of the bases. So the height of our trapezoid. And so to find the area of a trapezoid, what we do is we add our bases together. So we take the measurements of base 1 and base 2, and we add them together. Then we're going to multiply by the height of the trapezoid. We're going to add these two together and then multiply by the height. And then we're going to take half. So it looks similar to a triangle, like 1/2 base times height, but instead of having just one base to work with, now we have two. So we add those two bases together before we multiply by the height and then take half. Okay, and so these formulas may look a little complicated, but essentially what we do in our area problems is we look at the information we're given. Are we given the bases? Are we given the height? Are we given the area? And we plug in what we have to our formula. And then from that point on, either we're solving like a PEMDAS problem or we're solving an equation. So if we're given, for example, in a trapezoid, if we're given both bases and the height, all we really have to do is then just do a PEMDAS problem, add the two bases, multiply by the height, then take half. That's how we can find the area. If for some reason we're given the area and the bases and we need to find the height, that's a situation where we're gonna have to kind of solve an equation, right? So we'll have to do 1/2 and times whatever the bases are, and then use our division property of equality to find the area. So I'm going to do a separate video kind of showing you some examples that you can see, but essentially what we do is we take our information and plug it into our different formulas depending on the shape in order to find that space within it. So please make sure that you have all of these formulas written down. You can request to get a STAR reference sheet that also has these formulas on it if you would like to add that in your notebook or add it in your binder so you have it to reference. But now you guys are going to practice some examples of area to kind of see exactly how they look as either PEMDAS problems once you plug them in, or how they may look as equations.